Hello students, welcome back. In this video, we are going to discuss about specific heat capacity of different types of the molecules from chapter 13 Kinetic theory. Now, monoatomic molecule consider ಮಾಡಿದಾಗ it has only 3 degrees of freedom due to the translatory motion. And also we have seen that average energy of a molecule at temperature capital T is equal to 3 by 2 kBT. According to the law of equipartition of energy, 1 mole of monoatomic molecules in the ಆಗಿರುವಂತ ಗ್ಯಾಸ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಶುಡ್ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು U equal to 3 by 2 kBT into Na. Students, ಇಲ್ಲಿ 3 by 2 kBT is representing the energy associated with single molecule, and 1 mole of gas ಅಲ್ಲಿ there will be Na number of molecules, ಅಂದ್ರೆ Avogadro number of molecules ಇರ್ತಾ ಇರೋದ್ರಿಂದ total energy of the entire gas will be equal to energy associated with each molecule into the number of molecules present. That should be is equal to 3 by 2 RT, because we know that Kb into Na is equal to universal gas constant R. The molar specific heat at constant volume represented as Cv. Cv is equal to du by dt, which is in turn is equal to 3 by 2 R. ಹೇಗೆ ಬಂತು? First law of thermodynamics consider ಮಾಡಿದಾಗ we know that amount of heat supplied dq should be is equal to change in the internal energy plus the work done pdv. Constant volume ಅಲ್ಲಿ dv 0 ಇರ್ತಾ ಇರೋದ್ರಿಂದ we can see that dq must be is equal to du. Specific heat capacity definition ಪ್ರಕಾರ cv should be is equal to dq by dt for a 1 mole of substance. mu is equal to 1 ಇರೋದ್ರಿಂದ ಈ equation obtain ಆಗ್ತದೆ. ಇದನ್ನೇ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ and also we know that du is equal to 3 by 2 RT ಇರ್ತಾ ಇರೋದ್ರಿಂದ du by dt will be is equal to 3 by 2 R. Cv should be is equal to 3 by 2 R. Hence, for ideal gas, ನಾವು ಮೇಯರ್ಸ್ ರಿಲೇಷನ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ Cp minus Cv is equal to R, where Cp is the molar specific heat at constant pressure. Therefore, using the Mayer's relation, now specific heat capacity at constant pressure ಅನ್ನು find out ಮಾಡಬೇಕು, which will be is equal to 5 by 2 R. From the Mayer's relation, ನಮಗೇನು ಸಿಗ್ತಾ ಇದೆ? Cp should be is equal to Cv plus R ಇದೆ, and previous slide ಅಲ್ಲಿ ನಾವು ನೋಡಿದ್ದೇವೆ Cv is equal to 3 by 2 R ಇತ್ತು plus R, that will be is equal to 5 by 2 R. Ratio of specific heat capacities represented as gamma is equal to Cp divided by Cv find out ಮಾಡಬಹುದು, which is equal to 5 by 3, because Cp is equal to 5 by 2 and Cv is equal to 3 by 2. ಇಲ್ಲಿ 2 and 2 get cancelled, hence we will get gamma is equal to 5 by 3. Now we are going to consider specific heat capacity of diatomic molecule. Diatomic molecule ಅಲ್ಲಿ ನಾವು ಎರಡು ಕೇಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೇವೆ. First, rigid rotator. That means no vibrational motion. Vibrational motion ಇಲ್ಲದಿದ್ದಾಗ diatomic molecule ಗೆ there are 5 degrees of freedom. 3 ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಮೋಷನ್ ಆಗಿದ್ರೆ 2 rotational motion ಇಂದಾಗಿ ಬರ್ತಾ ಇರುವಂತ ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್. According to the law of equipartition of energy, total energy of such molecule which is having 5 degrees of freedom should be is equal to 5 by 2 kBT into Na. 1 mole of substance again consider ಮಾಡಿದ್ದೇವೆ. Energy associated with single molecule of diatomic molecule is equal to 5 by 2 kBT. Number of molecules present in 1 mole of a diatomic substance will be is equal to Na. Multiply ಮಾಡಿದಾಗ we will get total energy of entire sample. 1 mole of diatomic gas ಗೆ it should be is equal to 5 by 2 RT. Similar fashion, ನಾವು ಈಗ molar specific heat capacity at constant volume ಅನ್ನು determine ಮಾಡ್ತಿದ್ದೇವೆ, which is given as Cv is equal to du by dt. Again, constant volume ಇದ್ದಾಗ dq is equal to du ಆಗ್ತವೆ, and 1 mole of a substance ಗೆ Cv is equal to du by dt ಆಗಿದೆ. Hence, it should be is equal to 5 by 2 R. ಮೋನೋ ಅಟಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ ರೀತಿನೇ ನಾವು ಪ್ರೊಸೀಡ್ ಮಾಡಿದಾಗ ಫಾರ್ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅಗೇನ್ಸ್ ಮೇಯರ್ ರಿಲೇಷನ್ ಅನ್ನ Cp ಮೈನಸ್ Cv ಇಸ್ ಈಕ್ವಲ್ ಟು R ಅನ್ನ ಯೂಸ್ ಮಾಡಿದಾಗ we can find out the specific heat capacity at constant pressure. Cp should be is equal to Cv plus R, which should be is equal to pi by 2 R plus R. In turn, it will be is equal to 7 by 2 R. Therefore, the ratio of specific heat capacities at constant pressure to that at the constant volume should be is equal to 7 divided by 5. Students, remember that the ratio of specific heats, gamma does not have any unit. This is unitless quantity. This is pure number. Next, we are going to consider diatomic molecule, which is non-rigid rotator. That means, in addition to the 3 degrees of freedom due to translatory motion and 2 degrees of freedom due to the rotatory motion, it will also have a vibrational motion. Vibrational motion ಇಂದಾಗಿ ಎರಡು ಎನರ್ಜಿ ಟರ್ಮ್ ಬರ್ತಾ ಇದೆ, kinetic plus potential. Therefore, total energy or internal energy of diatomic molecule which is non-rigid rotator should be is equal to pi by 2 kBt plus kBt. ಯಾವಾಗ ನಾವು 1 mole of such gas ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದೆವೋ ಆವಾಗ ಟೋಟಲ್ ಎನರ್ಜಿ ಆಫ್ ಈಚ್ ಮಾಲಿಕ್ಯೂಲ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರೆದಿದ್ದಾಗೆ ಇರಬೇಕು, 5 by 2 kBt plus kBt. ಬಟ್ 1 mole of a substance ಗೆ it should be is equal to energy associated with single molecule into the number of molecules present in 1 mole, Avogadro number, which is equal to 7 by 2 RT. ಇದೇ ರೀತಿ ಪ್ರೊಸೀಡ್ ಮಾಡಿದಾಗ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಕೆಪಾಸಿಟಿ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ನಮಗೆ 7 by 2 R ಬರ್ತಾ ಇದೆ. Specific heat capacity at constant pressure 9 by 2 R ಬರಬೇಕು. Hence, the ratio of specific heats gamma should be is equal to 9 by 7 ಬರಬೇಕು. If we consider polyatomic molecule, generalize ಮಾಡ್ತಿದ್ದಾರೆ. So, which will be having 3 or more than 3 atoms ಇರುವಂತ molecules consider ಮಾಡಿದಾಗ, it will have 3 degrees of freedom due to the translatory motion, 3 degrees of freedom due to the rotational motion, and depending on the structure of the polyatomic molecule, F number of vibrational modes of energies ಇರಬೇಕು. ಈ ಜನರಲ್ ಟರ್ಮ್ F ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೀವಿ. Then according to the law of equipartition of energy, 1 mole of such gas ಗೆ internal energy ಎಷ್ಟಿದೆ ಅಂತ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು, which is represented as U, and it is equal to energy due to the translatory motion plus energy due to the rotatory motion plus energy due to the vibratory motion. F modes of energy, the energy associated with each mode is equal to kBt, kinetic plus potential irta irodrinda, into the number of molecules present in 1 mole of a gas, Na. We will get, it should be is equal to 3 plus F into RT. Easy. 3 by 2 kBt plus 3 by 2 kBt will be is equal to 6 by 2 kBt, or that will be is equal to 3 kBt ಬರ್ತಾ ಇದೆ plus F kBt. ಇಲ್ಲಿ ಕಾಮನ್ ಇರುವ kBt ಅನ್ನು ಹೊರಗೆ ತಗೊಂಡು Na ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ we will get R. The remaining term will be is equal to 3 plus F RT. The expression for the CV, specific heat capacity at constant volume, should be is equal to 3 plus F into R, and Cp is equal to 4 plus F into R. Hence, the ratio of specific heats gamma must be is equal to 4 plus F divided by 3 plus F. This equation is valid for all the type of polyatomic molecules. This is general expression. Determination of specific heat capacity of solids. ಇಲ್ಲಿ ನಾವು n number of atoms ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೇವೆ. ಸಾಲಿಡ್ಸ್ ಅಲ್ಲಿ ನಾವು ಮಾಲಿಕ್ಯೂಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. It will be atoms, and each atom will be vibrating about its mean position in one dimension. Average energy associated with each atom should be is equal to 2 into half kBt, which is equal to kBt. Reason simple, potential ಮತ್ತು kinetic energy associate ಆಗ್ತಾ ಇರೋದ್ರಿಂದ vibratory motion ಗೆ energy associated with each mode half kBt into 2, that will be is equal to kBt. In 3 dimensions, the average energy is equal to 3 kBt. ಯಾಕಂದ್ರೆ ಸಾಲಿಡ್ಸ್ ಅಲ್ಲಿ atoms they cannot leave its position. ಇದು ವೈಬ್ರೇಟ್ ಆಗಬೇಕಿದ್ರೆ either ಈ ರೀತಿ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗ್ಬೋದು, ಅಥವಾ ವೈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗ್ಬೋದು, ಅಥವಾ ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗ್ಬೋದು. ಒಂದು ಡೈಮೆನ್ಷನ್ ಗೆ ಎನರ್ಜಿ ಅಸೋಸಿಯೇಟೆಡ್ ಕೆಬಿಟಿ ಆದ್ರೆ 3 ಡೈಮೆನ್ಷನ್ ಗೆ ಫಾರ್ ಎ ಸಿಂಗಲ್ atom it will be is equal to 3 kBT. When we consider 1 mole of a solid, ಆವಾಗ ಏನಾಗಿದೆ, number of atoms present should be is equal to Avogadro number. Hence the total energy of the solid should be is equal to energy associated with single atom into number of atoms, Avogadro number, which is equal to 3RT. At constant pressure we know that first law of thermodynamics ಏನ್ ಸಜೆಸ್ಟ್ ಮಾಡ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಡೆಲ್ಟಾ ಕ್ಯೂ should be is equal to delta U plus P delta V. In case of the solid, change in the volume almost 0 ಇರ್ತಾ ಇರೋದ್ರಿಂದ work done is almost 0. Therefore ನಮಗೇನ್ ಸಿಗ್ತಾ ಇದೆ, delta Q is equal to delta U ಬರ್ತಾ ಇದೆ. Hence specific heat capacity ಅನ್ನ ತಗೊಂಡಾಗ ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಗೇನ್ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಅನ್ಲೈಕ್ ಗ್ಯಾಸ್ ಇಲ್ಲಿ 2 ಟೈಪ್ ಆಫ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಕೆಪಾಸಿಟಿ ಇಲ್ಲ. ಇಟ್ ಈಸ್ ರಿಪ್ರೆಸೆಂಟೆಡ್ as C only. Molar specific heat capacity of the solid is given by the expression delta Q divided by delta T into 1 by mu. 1 mole of a substance consider ಮಾಡ್ತಾ ಇರೋದ್ರಲ್ಲಿ mu is equal to 1 ಇದೆ, and constant pressure ಅಲ್ಲಿ the change in the volume negligible ಇರ್ತಾ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ delta Q is equal to delta U ಇದೆ. Hence we will get C is equal to delta U by delta T. Therefore C must be is equal to 3RT divided by dt ಬರ್ತಾ ಇದೆ. Hence C must be is equal to 3R ಬರಬೇಕು. Finally we are going to determine the value of specific heat capacity of water. Determination of specific heat capacity of the water is very easy. ಯಾಕಂದ್ರೆ ನಾವು ವಾಟರ್ ಅನ್ನ ಸಾಲಿಡ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ತಿದ್ದೇವೆ only for determination of the specific heat capacity. Therefore ಪ್ರತಿಯೊಂದು ಅಟಮಿಗೂ ಸಾಲಿಡ್ಸ್ ಅಲ್ಲಿ ಎವರೇಜ್ ಎನರ್ಜಿ ಅಸೋಸಿಯೇಟೆಡ್ ಎಷ್ಟಾಗಿರ್ಬೇಕು, ಪ್ರೀವಿಯಸ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ನೋಡಿದ್ದೇವೆ 3 kBT. ಬಟ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ದೇರ್ ಆರ್ 3 ಐಟಮ್ಸ್, 2 ಹೈಡ್ರೋಜನ್ 1 ಆಕ್ಸಿಜನ್. Therefore total internal energy should be is equal to energy associated with single atom into number of atoms present in a molecule. 9 kBT ಆಗ್ತಾ ಇದೆ. 1 mole of water consider ಮಾಡಿದಾಗ there will be Avogadro number of molecules present. Hence it should be is equal to 9 RT for 1 mole of water. Therefore specific heat capacity of the water, as we have observed, it should be is equal to 9 R. According to the classical law of equipartition of energy, the predicted specific heats are independent of temperature. Law of equipartition of energy ಪ್ರಕಾರ specific heat capacity ಏನು, it should be independent of the temperature. ಇಲ್ಲಿಯವರೆಗೆ ನಾವು ಡಿಟರ್ಮಿನ್ ಮಾಡಿದ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಕೆಪಾಸಿಟೀಸ್ ಡಿಫ್ರೆಂಟ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಗ್ಯಾಸ್ ಇರ್ಬೋದು, ಅಥವಾ ಸಾಲಿಡ್ಸ್ ಇರ್ಬೋದು, ವಾಟರ್ ಇರ್ಬೋದು, ಟೆಂಪರೇಚರ್ ಅನ್ನು ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇರುವಂತ ಕ್ಯಾಪಿಟಲ್ ಟಿ ಅಪಿಯರ್ ಆಗ್ತಾ ಇಲ್ಲ. ಬಟ್ ಯಾವಾಗ ನಾವು ವೆರಿ ಲೋ ಟೆಂಪರೇಚರ್ ಗೆ ಹೋಗ್ತಾ ಇದ್ದೇವೋ ಆವಾಗ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಕೆಪಾಸಿಟಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. We can see that specific heat of all the substances will become zero at absolute zero temperature, which shows that there should be dependence of specific heat capacity on the temperature. ಇದರಿಂದಾಗಿ ನಮಗೆ ಕ್ವಾಂಟಮ್ ಥಿಯರಿಯ ನೆಸೆಸಿಟಿ ಅರೈಸ್ ಆಯ್ತು. ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕ್ವಾಂಟಮ್ ಥಿಯರಿ, ಈ ವೇರಿಯೇಷನ್ ಇನ್ ದ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ಸ್ ವಿತ್ ಚೇಂಜ್ ಇನ್ ದ ಟೆಂಪರೇಚರ್ ಹೇಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಅಟ್ ಅಬ್ಸಲ್ಯೂಟ್ ಝೀರೋ ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್ ಏನಾಗಿದೆ, ದೇ ವಿಲ್ get frozen. Therefore they will become ineffective at very low temperatures. Degrees of freedom ineffective ಆದಾಗ obviously ಏನಾಯ್ತು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ specific heat capacity should become zero. Students, I hope you have understood the concept of determination of values of specific heat capacities using the kinetic theory. Thank you for watching the class. Stay safe and happy learning.